A very useful cousin of a function is called the function's inverse. Do you remember a special type of function called a one-to-one function? Well, what made it special? First of all, every element in the domain was paired with a unique element in the range. That's what made it a function, period. Boring. What makes it a one-to-one function is that it works the other way as well. It's a special type of function that every element in the range is paired with a unique element in the domain. In other words, it works backwards. Every x is paired with only one y, and every y is paired with only one x. Now, while a function is basically a path, if you would, to get from x to y, the inverse of a function is the way to get back. I say to get back from y back to x. Now, consider the reason we're talking about one-to-one functions is unless you're working with a one-to-one function that works both ways, if you would, there isn't a way back. So you only have an inverse of a function, or a function only has an inverse if it is in fact originally a one-to-one function. Otherwise, there's no way back anyway.
Allow me to demonstrate.
Now, this relation is a function. It gets the function seal of approval.
Excellent.
Because no x is paired with more than one y. The inverse of it would be just flipping the domain and the range. It's very simple, but that's the idea of the inverse. The inverse is going to map the range back to the domain, or the y's back to the x's. Now, this isn't always that simple.
Direction unclear. Please repeat request.
Let's look at this relation. Now, every x is paired with only one y, so it is a function. It does get the function seal of approval. All the x's are in fact different. If we tried to find the inverse of it, basically by flipping the x's and the y's, well, in this case, all the x's aren't different. So while it would have been an inverse, it's not an inverse function. And the reason for that,
Very bad. Definitely unacceptable. Yeah.
the inverse isn't a function, is because the original function wasn't a one-to-one function, was it? It was a function, but it wasn't a one-to-one function.
You can't handle the truth.
So we'll have to start with a one-to-one function in the first place to even have an inverse ever.
Pay attention, boys. I'll show you how it's done.
Here is how we find the inverse formula of a function. There's 4 steps. A lot of this is just notation changes. For instance, the first step is to replace the f of x with what it really is, the y. Then we're actually going to interchange the x and the y in the equation, flip them, and then here's something you should be good at. We're going to solve for y. Once we've solved for y and we've gotten y by itself, we're going to replace that y with the notation for f inverse of x, and that's written f minus 1 of x. Okay, it doesn't mean to the negative 1 power. It means the inverse function of x.
I don't understand.
Okay, well, let's try one. We're going to try and find the inverse of this function, f of x. The first thing we'll do is replace f of x with y. Okay, there you go. Second step, interchange the x and the y. So I'll write the function normally, except I'll interchange the x and y. Okay, that's the second step. Now the third step is to do whatever it takes to solve for y. In other words, get y by itself. Now, who's keeping y from being by itself? If you look at them, the 4 is. So I'll subtract 4 from both sides, and y will equal x minus 4. That's basically the inverse function, but for notation's sake, the fourth step is to replace the y part with the notation for that, f inverse of x. And that's the inverse. That's the inverse function of x in this case. Recall that the original function will take any x that you put in, any value for x, and pair it with a new y. We like to say map every x to its own unique y. The inverse function is going to get you back from that y back to x. Interestingly enough, you can test whether you're correct, whether you've found the correct inverse function, by doing something that we just covered called compositions. Okay? If we compose the inverse function with the original function, or f inverse of f of x, it should bring us back to x. And let's try that.
Let's play. Here we go.
We're going to find the composition of the inverse of f of x.
I know that, dude.
Okay? So we're going to take the inverse of the original function. Now the inverse function is x minus 4. So we're going to replace x minus 4, the x portion of that, with the original function. I like to use parentheses here. And now I'll simplify.
Oh, yes.
And look what I end up getting back to. The mother lode x. And that's how I'll know I check. If I can compose f inverse with f of x and I get back to x, well then I know I have the right inverse.
Prepare to be astonished.
And cool as a mule, you know what? If we actually graph any function and on the same picture graph its inverse, I want to show you what happens. Let me graph the original function. I'll get 3 easy points. Let me plug in 0, 1, and negative 1 because they'll fit on the graph. If I put in a 0, I get 4. If I put in a 1, I get 5. And if I put a negative 1, I get 3. If I graph these 3 points, they line up, and there's the original function. Y, or f of x, equals x plus 4. Now if I do the inverse function, I'll try the same 3 points, 0, 1, and negative 1. I get 0, negative 4, 1, negative 3, and negative 1, negative 5. And if I graph those, they also line up, and the inverse function in blue there graphs right there. Now, what will always happen when you graph a function and its inverse function, since one is the, if you would, interchanging of x and y, is that they will be a mirror of each other about the line y equals x. I could actually fold this graph on the dotted line, which is the graph of the line y equals x, and the red would end up on top of the blue. That'll always happen.
Making copies.
Okay? So the graphs of inverse functions always mirror each other about the line y equals x. That's another test that you could use on your calculator even. Let's try another. We're going to find the inverse of this function. The function f of x equals 3x plus 2. We need to find out what function would get us back from y back to x. Well, remember the steps. Replace f of x with y, because that's what it really is. And then rewrite the whole equation interchanging x and y. Okay? Now, solve the equation for y. Get y by itself. Now, I have 2 things keeping y from being by itself. The 2 and the 3. Let me subtract 2 from both sides. And I'll get x minus 2 there. I can't do anything there. Now divide both sides by 3 to undo the 3, and y will equal x minus 2 over 3. Now the last step is to replace the y with the notation f inverse of x. Now, this doesn't surprise me much that the inverse of multiplying by 3 and adding 2, the inverse of that is subtracting 2 and dividing by 3. It's just the opposite operations, isn't it?
Woohoo! Come to Papa.
So there's your inverse function. Now,
And you're going to do it because I said
let's
so.
test it out. Not because I said so, but just to practice with compositions. Remember that if we compose each, we should end up back at x. The composition of f inverse of x and f of x should get me back to x. Let's try it. There's the inverse function, and I'm going to replace x with the original function 3x plus 2. Now let me simplify. The 2's cancel, and the 3's cancel, and what's left? There he is, x. We got back to x, so I must have found the correct inverse function.
Hey, you're plumb right, Farman.
Pretty cool, huh? Let's do the other test.
Now look at, I say look at here.
Let's graph both the original function and its inverse and see if it mirrors about the line y equals x. The original function, I'll put in these 3 values, and I'll get these 3 points. Now it's a little bit different than our picture before, but they do line up. Now the inverse function, let me get 3 points for him. And let's see, let me graph those points. Looks different. They do line up. And son of a gun, if you draw the line y equals x, and if you fold it on that dotted line, that red would end up on top of that blue. So the graphs of inverse functions always mirror each other about the line y equals x, meaning that you could fold your graph over the line y equals x on the dotted line, and they'd fall on top of each other.
Does everybody know what time it is?
Okay, let's go practice it. Go do that homework.